Hi, let's now start Module 8, Verification of Renewable Energy Forecast, with its first block, what makes a good forecast? A good forecast or a bad forecast is almost a philosophical problem. Many authors throughout history have worked on this problem, but here I've selected Murphy, who is cited at the top, for his vision on the nature of goodness in weather forecasting. Even though he focused on weather forecasting, you will see that the concepts described in his work are actually applicable to renewable energy generation, but also to other types of forecast. Following Murphy, the nature of goodness in forecasting consists in, first of all, forecast consistency, and this means that the forecast should correspond to the forecaster's best judgment on future events based on knowledge available at the time of issuing the forecast. If you were to reinterpret this definition, that means that the forecaster should have an incentive to do his or her best when generating and delivering forecasts to a forecast user. You will see through an illustrative example, this may not always be the case. Then beside forecast consistency, there is forecast quality, which is a more scientific view of how close the forecasts are to what really happened. So a formal definition should be that forecasts should describe future events as good as possible, and this is regardless of what this forecast may be used for. This could be for market participation, let's say for renewable energy forecast. This could be for reserve quantification. Whatever decision-making problem you're thinking of, you would like the forecast to describe as close as possible what really happens. Eventually, there is forecast value, and there you look at the decision-making problems. So forecast should bring additional benefits. This can be monetary, but maybe some other benefit when used as input to decision-making. Think of the case of market participation, which we covered in previous modules. When you have two forecasts that you use for market participation, maybe one forecast is going to give you higher revenue than the other forecast, but maybe the second forecast was actually better at describing what really happened than the first forecast. So one of the forecasts seems to have higher forecast quality, but the other forecast has higher forecast value since it's bringing you higher revenues. If you would like to dig a bit more on these concepts of goodness in forecasting, I would like to invite you to read this paper by Murphy, where you can get the PDF by clicking on this link. Now let's focus on an illustrative example. There will be two, where we're going to go through some of these concepts through practical cases. So first of all, consider you are in charge of optimal maintenance planning at Horns Reef, and you have booked both a vessel and a helicopter for on-site service. This has cost you 100,000 euro. The condition for you can actually visit the wind farm is that wind speed has to be less or equal than 15 meters per second, and then wave height has to be less or equal than 1.8 meter. If these conditions are not fulfilled, you cannot access the site. So these conditions are for the time of the visit, that we denote T plus K, but 24 hours before service, that we denote time T, this is your last chance to cancel before you would have huge financial penalties if you were to cancel in this last 24-hour window. The penalty for cancelling would be 100,000 euro, so it's very important for you to get a forecast, look if these conditions are going to be fulfilled, and decide if you're going to visit the offshore wind farm or not. For that, you have two forecasters that are called Foresight and Blind Spot, and they tell you that Foresight is saying wind speeds will be 12.6 meters per second. Wave height will be 1.6 meter. In parallel, Blind Sight is telling you that wind speed is going to be 3.4 meters per second and wave height is going to be 0.2 meter. This looks quite different, but in view of the conditions that you have for visiting the offshore wind farm, in both cases you go ahead with the planned service. After you reach the time of the visit, you can see what actually happened. You can measure the wind speed, you can measure the wave height, and we can compare with the forecast. So remember the forecast of foresight and blind spot here, and this is what was actually measured on site. Wind speed at that time was 12.3 meter per second, wave height was 1.45 meter. If you compare these values to the foresight and the blind spot forecast, you see a big difference. So the actual measurements are much closer to what foresight predicted, but still, if you consider your overall cost, you made the right decision by going, and your overall cost is 100,000 euros for originally booking the vessel and the helicopter, but you didn't face this additional penalty by having to cancel within the last 24-hour window. So thinking of our forecast attributes that we mentioned originally, both foresight and blind spot, since they make you make the right decision, their value is good. Both of them have good forecast value. But in terms of the quality of the forecast, while foresight doesn't seem to be so far from what really happened, blind spot is completely off. So even though you get forecast value, maybe you don't get so much forecast quality from blind spot. Let's look at another illustrative example where we revisit a tale from ancient Greece, The Boy Who Cried Wolf. For those who are interested, you can just find this tale everywhere online, and then you will see how our story relates to it. So here we focus on Rogue Trading. That's a company that made huge losses last year due to expensive upregulation events in the electricity market. So therefore, Rogue Trading decided to get a new forecaster that would be good at predicting those upregulation events. There are two companies, two forecasters in competition. They are Foresight and Blind Spot, these companies we just met before, and so they are in competition for getting the job. Since there is a competition, one defines a period, let's say of 1 year, and there is a score. You want to be able to calculate this score and then decide based on the score value which one of the two is best for the job. The score is simple. We call it SC here, and the score is going to consist in dividing the number of events leading to upregulation that were predicted by the number of events leading to upregulation. We scale this score, multiplying it by 100, so that the higher the better, and 0 is the worst, 100 is the best. Based on the setup for this competition, if you were Foresight and Blind Spot, what would you do? Do you have a specific strategy in mind? Let's look at the strategy of our two competitors. In the first case here, Foresight has a strategy which is to always predict a need for upregulation. It's like thinking of going to the desert and making a weather forecast. It's going to be sunny. It's going to be sunny all the time. We're in the desert, sounds quite okay, but if you were in Denmark, for instance, and you start saying, my strategy for forecasting, I'm going to say that it's sunny all the time, maybe it's not going to work so well. So keep it in mind, Foresight is always predicting the need for upregulation. On the other side, the strategy of Blind Spot is to design a model and really do the best possible to find when upregulation will occur. The results over this period of 1 year, so with hourly resolution, we have 8,760 hours or market time units. They are here. The number of events that were leading to upregulation last year were 3,237, and then the number of events predicted by Foresight that were leading to upregulation were 3,237. Obviously, since predicting all the time there was going to be upregulation, they have it right in terms of the right times for upregulation. And then looking at Blind Spot, the number of events leading to upregulation that were predicted were 2,500. If you calculate the score values, you can see that Foresight has a score of 100, this number divided by this number times 100, and then blind spot has a score of 77.2, this number divided by this number times 100. So eventually, that means that foresight gets the job. Does that seem fair to you? Do you really think that foresight is the best? Well, what would happen? The consequences of that would be that even though never missing on upregulation event, rogue trading now is always missing on the downregulation ones. Obviously, because foresight is saying it's always going to be an upregulation event. So eventually, the financial losses may still be there and possibly even higher than expected. What we have to think of is that maybe it's just that the problem setup was not right. You didn't invite for forecast consistency. You didn't invite for the forecasters to do their best to provide forecast for your purpose. So here, let's look at a more consistent way to evaluate these forecasters. That would be to consider these confusion matrices or contingency tables, where we look at event predicted, event not predicted, the event happens, or the event doesn't happen. In the case the event is predicted and it happens, we call it a hit. In the case the event is not predicted but it happens, we call it a miss. In the case the event is predicted but nothing happened, it's a false alarm. And in the case the event is not predicted and it doesn't happen, it's a correct rejection. So we're going to count the number of cases for these four types, and then we're going to keep these tables and calculate a score based on it for both forecasters. So we'll have a table for foresight, we'll have a table for blind spot, and we can now introduce a score that will be proper, so ensuring forecast consistency, which is going to be the number of hits divided by the number of hits plus the number of misses plus the number of false alarm. This score is actually called the threat score, and we know it is proper in the sense we're going to have forecast consistency. And here again, by multiply it by 100, 0 is worst and 100 is best. In the present case, if we look at the various entries of these contingency tables for foresight and blind spot, we have the number of hits that we have from before, so 3,237 for foresight, 2,320 for blind spot. Then we have a number of misses, which are 0 for foresight, 917 for blind spot. Then the number of false alarm, 5,523 for foresight, obviously because it's always predicting upregulation even though it doesn't happen. And then you have 180 false alarms for blind spot. Finally, the correct rejections are 0 for foresight, and there are 5,343 for blind spot. Calculating the value of the threat score, we get foresight with a score of 36.9% and blind spot with a score of 67.9%. So the conclusions are that if you use a proper score and ensure forecast consistency, then you would have a totally different outcome, and most likely it is a good idea to contract blind spot for the job. Now, when we discuss the practicalities of assessing forecast quality, value, and consistency, we need a test case that is properly designed. In the following blocks, we'll use the case of the Klim wind farm in Denmark as a basis for all our illustration and examples. This Klim wind farm is located here in the north of Jutland. It is an onshore wind farm, and it's a quite old one. It was commissioned in '96. So actually, the original wind farm is not really there anymore. It's been decommissioned and recommissioned a few years ago. The data we have is for the period 1999 to 2003, so the first version of the wind farm, and it has 21 megawatt based on 35 wind turbine. The average annual electricity generation is 49 gigawatt hours. We will have forecasts that are deterministic and probabilistic, since we will discuss these two types of forecasts in the next blocks. And then originally we have data with temporal resolution of 5 minutes, but eventually we go to hourly averages consistent with the market time unit resolution in the North Pole. When we want to look at forecast quality, value, and consistency, we have to remember that forecast is about future events, new situation, and we don't try to forecast the past or even explain what happened in the past. So if we play a lot fitting models, tuning parameters based on past data, and we want to draw conclusions directly on this past data, it might actually not be such a good idea. This would lead to what is generally coined overfitting. So what we have to do in practice is that when we have a lot of data, so let's say here you have 1 year of data, but this could be more, you would use a part of the data for modeling, and there you can do whatever you want. You can try different models, you can tweak the parameters, everything you feel like. But then at a certain time, you say this is over, and now whenever I apply my models, it's as if we were in operational conditions, it's genuine forecasting. And at the end of this period that we call the evaluation period, we can calculate some scores that will truly tell something about the genuine forecast quality. In this module, we will most often focus on this period, so the last 6 months of 2002, even though we'll have also some example for some other periods. Thank you very much. I would like now to invite you to use the self-assessment quiz to check your understanding.